Back to my channel. Hope everyone is doing great in their life. Let's solve today's Leetcode problem 3147, taking maximum energy from the mystic demons. Okay, so there were actually n mystic demons. Okay, there were n magicians, and each magician has a particular energy associated with them. Okay, so the energy associated with the first magician is 5, energy associated with the second magician is 2, and so on and so forth. Okay, there is a possibility that each magician can hold a positive energy and a negative energy. Okay, if you and whenever you start at a particular magician, okay, there is a curse that you will observe all the energy from the magician and you will jump to the kth magician from there. Okay, so here the k is equal to 3, so if you start at this magician, you will jump to this magician and you will observe the energy. Okay, once you start observing the energy from any particular magician, no matter how many after taking gems, you must have to observe the energy. There is no option for skipping. Okay, let's say I've started over here, I jumped over here, you have to observe the energy. There is no, you cannot skip the energy. Okay, so you have to return the maximum energy you can gain from all these magicians. Okay, so I've taken the same example and I've pasted over here. Okay, so here if you see, there were 5 magicians and the corresponding energies and k equal to 3. That means whenever you start at a magician, you have to take a jump of 3. Okay, so there are different possibilities. Okay, so either you can start at the first magician or at the 0th index magician and observe the energy and jump to the third magician, and again you take a jump. So in this process, the total energy you have gained is basically 5 plus minus 5, which is 0. Okay, that is one possibility. I can either choose to start at position 1. So in this case, you will first observe the energy of this magician, which is 2, and you will take a jump of 3 and you will observe the energy of this magician as well. So the total energy gained is basically 1. Okay, so far previously you have gained an energy of 0, now you have gained energy of 1, so the maximum energy gained so far is basically 1. Okay, now either you can, now the third possibility is you can start at this particular index, you gain this energy which is minus 10 and take a jump of 3. There is no other magicians available, so energy gained in this process is basically minus 10, but the maximum energy gained so far is again 1, which is still the possibility where you have started from this index. So this is one approach where you basically start at all possible magicians and check and get and identify the maximum energy you can gain. Okay, so in this process, okay, since once you have started at this index, you are jumping to a particular index. Okay, so there is if we already know the maximum energy you can gain by starting at this particular index, then you would have directly called you can directly sum the magic of this energy of this magician plus the maximum energy you gain by starting at this index. Okay, so in the recursive approach, what we do is basically we try to memorize the maximum energy you can gain. Okay, so in the recursive, as I mentioned, you can start at any particular index and you have to recursively call the maximum energy. Okay, so here n is, I just wrote the code where n is the length of the energies, and initially I have defined a variable called energy, which is integer minimum value. Since we want to our aim is to maximize the energy, so I have initialized this value with the minimum value, and I have defined an array, okay, called max, which will help us to memorize the energies. Okay, so max of I will tell the maximum energy you gain when you start at the ith index. Okay, if you start at the ith index and you try to gain the energies, then what would be the energy in this particular approach? Okay, that will tell max is basically used for that. Initially I filled all the values with minimum values. Now as I mentioned, I will start at each index and try to calculate the maximum energy I can gain. Okay, so I have written a function called max energy, which will take the energies array and k, which is the gems, and if the index at which I am going to start and the energy so far I have. Okay, when I start initially, if I start here, I don't have any energy which is 0, so I will start with energy 0. If I start from this index, initially energy was 0, so that is what I am passing here. Okay, so once I start from a particular index, okay, I have to consider the energy of that particular index and I have to calculate the energy after taking the k jump. Okay, so I am recursively calling the same function here by just updating the index, and what will be the energy if I ideally start at that particular index, okay, which is I plus k. So this will give me the energy if I start at I and take a jump of I plus k. Okay, so if I already calculated the energy at that particular index, I don't have to recompute the calculation. I will just return the value from my the max array. So this way we are actually not computing the things again and again. Okay, so if you just and I'm actually trying to, at each step I'm getting the maximum of the energy. So if I just call this particular function energy followed by k, and if I return it, so here we are using an extra space of if you see this, it has satisfied all the test cases, but the time complexity here will be linear only because we are starting at each index and we are trying to memorize the previously computed results. Okay, so space complexity is also order of n and time complexity is also order of n, but we can still optimize this solution. Okay, the other approach is basically using iterative approach. Okay, so if you keenly observe, okay, if I no matter at what index I start, okay, I will basically end up landing at a particular index. Okay, so you will, if k equal to 3, that means you will for sure land in one of these indexes if you start at any index before it. Okay, if you don't choose to start any index before, that means you have to pick one of these indexes, right? In the worst case, yeah, so let's say I have started at this index, the last index. Okay, either I choose to start at this index or I choose to land at this index. There are only two possibilities for any index. Okay, either you choose to start at this index or you have to end at this index. If I start at this particular index, the energy gained will be -1. Okay, if I choose to end at this index, that means I have to take k jumps in the backward direction and calculate the energies, so on and so forth, right? If I take a first jump of k and if I just sum with the existing energy, which is -1 and 2, this will tell me that if I choose to start at this index, then the energy would be 2 plus 1. Okay, instead of going in the forward direction, if I start at this index and landing at the index, we are going in the reverse direction. I will end at this index, and from which index I can come? I can come from this index. Okay, so this will tell me if the energy gained by starting at this index. Again if I take a k jump, that will tell me the energy you will get by starting at that particular index. Okay, using this approach, we can basically, we don't have to keep an extra memory. We just need a variable to calculate the current energy, and we will keep on updating our max energies accordingly. Okay, so in the iterative approach, as I mentioned, we can land it in any one of these indexes. So this index is basically n minus k. You can land at this index and all the way up to n minus 1 indexes, and we are incrementing by 1. So initially I have kept the sum as 0. Okay, and as I mentioned, from this index we have to jump in the backward direction. Okay, so I've written an inner loop which will tell me I will start at the particular index and jump by k elements, and I will go all the way till the 0th element. Okay, in each jump I will calculate my current energy. Okay, energy by jumping at the particular index, which will I just to do the sum. I just need to add the current energy to the existing energies, and then if I found that the new energy is actually greater than the so far energy I have, then I have to update my energy. So the sum, if the sum is greater than the answer, the so far energy I have, so I will update my answers. Okay, and in the end I will just return my answer, because in each iteration I am actually updating my answer with the maximum energy I have. So in the end, at the end of my iteration, I would basically have the maximum energy I could have gained in this entire process. Okay, so in this particular algorithm, okay, so if you see, the outer loop is starting at outer loop will do iterate for k iterations, whereas the inner loop will run for n by k elements. Okay, because we are jumping by k elements. Okay, so the overall time complexity here would be linear time itself. Okay, so yeah, that's all about this problem. Do subscribe to my coding channel for more such coding videos. Thank you.